Good morning, student. Here we have earlier started chapter number 7, coordinate geometry. Now, in part 1, we have discussed about the distance formula that is given by that is there are given 2 points A and B such that you can find the distance between these 2 points, that is a line segment. So we can find it by taking if coordinates of P is x1 y1 and coordinates of P is x1 y1 and coordinates of Q is x2 y2. Then the distance between these 2 points is given by PQ, that is line segment, which is equal to square root of x2 minus x1 square or x1 minus x2 square plus y1 minus y2 minus y1 all square. Such type of, by this formula we can find the distance between any 2 points, and it is known as a distance formula that we have discussed. Now in this part we are going to discuss about the section formula. The section formula, let first consider one figure. As you can see here, given that we want to find the section formula. What is a section formula? There you can find that here given 2 points A, its coordinate is x1 y1, and here given point B, its coordinate is x2 y2. Now if we take any point on this line segment, if you take any point on this line segment as P, you can find here as P. Its coordinate is xy. Its coordinates is xy. So you can find that point P divides AB in such ratio. In some ratio, you can find that P divides AB in some ratio. So the part from A to P, let we say that the divided part A to P is M1 and P to B is M2. We take that P divides AB from point A. AP is M1 and PB is M2. If we say that P divides this AB from B, then M1 PB is M1 and PA is M2. So we consider here that you can say that P divides AB in such ratio M1 by M2. M1 by M2. So if you want to find the coordinates of this point P, if you want to find coordinates of this point P, x and y, so we use section formula. For that, so the coordinates of point P, x comma y, which divides the line segment joining the points A, x1 y1 and B, x2 y2 internally in the ratio m1 is to m2. So we want to find the coordinates of point x comma y, then coordinate x comma y is given by this formula. Here coordinates of point P, x comma y is equal to, here x comma y is equal to x comma y is equal to, the formula is given by m1 x2 plus m2 x1. Once again repeat that, m1 x2 plus m2 x1 divided by m1 plus m2. Here given the ratio m1 is to m2. So m1 part is distance between A and P, and m2 is the distance between P and B. So here m1 x2 plus m2 x1, which is divided by m1 plus m2, it is coordinate of x coordinate, and y coordinate is given by m1 y2 plus m2 y1 divided by m1 plus m2. So by this formula we can find the coordinate of this point, or if the given coordinate of this point which divides AB in such a ratio, then we can find ratio that divides P divides AB. So this is known as a section formula because P divide the AB in a section. So we can say that it is a section formula. So the coordinates of the point P, that is x comma y, is given by m1 x2 plus m2 x1 upon m1 plus m2 comma m1 y2 plus m2 y1 upon m1 plus m2. Now consider that there is given if this can also be derived by drawing perpendicular from A, P and B on the y-axis on proceeding as above. So we can also find the perpendicular, drawing perpendicular also we can find. So if the ratio in which P divides AB is K is to 1, what we can take? If the ratio in which P divides AB in K is to 1, we just say that K is to 1, then the coordinates of the point P will be kx2 plus x1 upon k plus 1 and ky2 plus y1 upon k plus 1. अगर जो है कि हम जो रेशियो है उसे हम k इज टू 1 ले ले तो डायरेक्टली हम p के कोऑर्डिनेट्स फाइंड कर सकते हैं. कैसे? तो k x2 प्लस x1 अपॉन k प्लस 1 एंड k y2 प्लस y1 अपॉन k प्लस 1. लेट वी टेक सम example. And now if what are the coordinate if p is midpoint of AB? What are the coordinates of point P if the P is midpoint? Because the ratio will be m1 and m2 will be equal. So the ratio, then after we can find the coordinates of midpoint as, here you can see it is a special case. The midpoint of line segment divides the line segment in the ratio 1 is to 1 because it is midpoint. So AP is equal to PB. AP is equal to PB means M1 is to M2 is equal to 1 is to 1. Therefore, coordinates of the midpoint P of the joining of the points A x1 y1 and B x2 y2 is, here m1 is 1 and m2 is also 1. So just put this value in the formula. We can find the formula is equal to x1 plus x2 upon 2 comma y1 plus y2 upon 2. It is a formula to find the midpoint of any line segment. It is formula to find the midpoint of any line segment or coordinates of any line segment. So using these three formula, let me solve some example here. Example number 6. Find the coordinates of point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3 is to 1. First let write it. It will be x1, it will be y1, x2 and it will be y2, and here it is m1 is to m2 means m1 is 3 and m2 is 1. So by using the formula, the x coordinate will be what will be m1 into x2. m1 that is 3, x2 that is 8 plus m1 that is 1 and x1 that is 4 upon m1 plus m2 which is equal to 7, and y coordinates is given by m1 into y2 plus m2 into y1 minus 3 upon m1 plus m2, which is equal to, therefore 7 comma 3 is the required point. By this way we can find also some question solution. Example number 7, in what ratio, now here we want to find m1 and m2, here we want to find m1 and m2. In what ratio does the point minus 4 comma 6, here given the coordinates of the point that divides a and b, in which ratio that we want to find, divides the line segment joining the points a 6 minus 6 comma 10 and b 3 comma minus 8. So here we want to find the ratio, means we want to find m1 is to m2. For that, here given point p, its coordinates, so just let we put, here we know that x comma y is equal to, x comma y is equal to m1 x2 plus m1 m2 x1 upon m1 plus m2, and m1 y2 plus m2 y1 upon m1 plus m2. So just put the value, here x comma y is given minus 4 comma 6, and m1 into x2 3, m2 into x1, that is minus 6, as well as m1 into y2 and m2 into y1 upon m1 plus m1. We don't know the value of m1 plus is to m2, so just put this value. Recall that if x comma y is equal to a comma b, then we can set x is equal to a and y is equal to b. So we can set x is equal to a and y is equal to b. So we can compare the both the quantities. Minus 4 is equal to 3, minus 4 is equal to 3m1 minus 6m2 upon m1 plus m2, and 6 is equal to minus 8m1 plus 10m2 upon m1 plus m2. Now from both one of them you can also find the value of m1 is to m1 m1 m2 from this equation, and also you can find from this equation. Just we take one of them, so here we take one of them. Minus 4 is equal to m 3m1 minus 6m2 upon m1 plus m2 gives, now just multiply this denominator with this numerator, and we can find next step, that is minus 4m1 minus 4m2 is equal to 3m1 minus 6m2. Now moving m1 on one side and m2 on another side. So here 4, and if we move 4m1 here, then 3m1 plus 4m1 which is equal to 7m1, and here we move 6m2 on here this side, then we find 6 minus 4, that is 2m2. Let move m2 here and 7 here, so we can find m1 is to m2 is equal to 2 is to 7, means the point minus 4 comma 6 divides given points a b in m1 is to m2 is equal to 2 is to 7. So let you can also verify that the ratio satisfies the y coordinate also. If you put these values, or let m1 minus m1 plus 10m2 upon m1 plus m2 which is equal to minus 8, we divide both denominator and numerator by m2. If you divide minus 8 m1 by m2, then you find minus 8 m1 by m2, plus if you divide 10 m2 by m2, that m2 m2 will be cancelled, then here 10, also m1 by m2 here, and plus m1 m2 by m2, that is 1. Why we have divided by m2? Because we have ratio m1 is to m2 is equal to 2 upon 7. So we want to find the ratio m1 upon m2, so that we can put the value 2 is to 7. So minus 8 into 2 by 7 plus 10, 2 by 7 plus 1 which is equal to 6. Hence we can verify such problems. Therefore, the points minus 4 comma 6 divides the line segment joining the points a minus 6 comma 10 and b 3 comma minus 8 in the ratio 2 is to 7. Alternatively, the ratio m1 m2 can also be written as m1 m2 is to 1 or k is to 1. We can take ratio m1 m2 is to 1 or k is to 1. We just take assume that k is to 1. Let p uh, that is minus 4 comma 6 divides ab internally in the ratio k is to 1. We just assume that it divides the ab in k is to 1 ratio. Using the section formula, we say that we have the formula minus 4 comma 6 is equal to 3 x k x2 minus x1 and k y2 plus y1 and upon x plus k plus 1. So just put 3k minus 6 upon k plus 1 and minus 8k plus 10 upon k plus 1. Then we find comparing one of them coordinate minus 4 is equal to 3k minus 6 upon k plus 1. So just to move k plus 1 here, so minus 4k minus 4 is equal to 3k minus 6, so 7k is equal to 2, then k is to 1 is equal to 2 is to 7. So it divides AB internally in the ratio k is to 1, that is 2 is to 7. By this formula also we can find. You can check for the y coordinates also. So the points minus 4 comma 6 divides the line segment joining the points a minus 6 comma 10 and b minus 3 comma minus 8 in the ratio 2 is to 7. Not that, you can also find the ratio by calculating the distances PA and PB and taking their ratio, provided you know that A, P and B are collinear. You can also find. Example number 8. Find the coordinates of the point. We want to find here coordinates of the point. Trisection of trisection. That's what is the trisection? That is points divides in 3 equal parts. Here we can say that P and Q. P and Q divides AB in 3 equal parts. AP is equal to PQ is equal to QB. AP is equal to PQ is equal to QB. This in 3 equal parts of the line segment joining the points A 2 minus 2 and minus 7 comma 4. Now just here we can find here 3 equal parts. So if we want to find the coordinates of point P, if you want to find the coordinates of point P, then you can easily say that it divides AB in 1 is to 2 ratio. AP is one part and PB is its double. So P divides AB in 1 is to 2 ratio. As well as if you want to find the coordinates of Q, then you can find that it divides AB in 2 into 1 ratio. It's 2 parts and it is 1 parts. So 2 is to 1 ratio. So by that way we can easily find both the coordinates of both the point. Let P and Q be the points of trisection of AB, that is AP is equal to PQ is equal to QB. Therefore, P divides AB inertially in the ratio 1 is to 2 because here 3 equal parts. So, P divides 1 is to 2. Therefore, the coordinates of P by applying the section formula are, that is m1 x2 plus m2 x1, that is 1 minus 7 plus 2 into 2 upon 2 1 plus 2 and m1 y2 plus m2 y1, that is 1 4 1 into 4 plus 4 2 into minus 2 which is upon 1 plus 2, then that is coordinates minus 1 comma 0 And about the coordinates of q, you can find it's also that q also divides ab internally in the ratio 2 is to 1. So the coordinates of q are 2 into minus 7 plus 1 into 2 upon 2 plus 1, and also 2 into 4 plus 1 into minus 2 upon 2 plus 1, that is minus 4 comma 2. So by this way, using section formula, we can find the coordinates of any point, or also the ratio that it divides the given line segment. Therefore, the coordinates of the point of trisection of the line segment joining A and B are minus 1 comma 0 and minus 4 comma 2. Note that we could also have obtained Q by noting that it is the midpoint of PB. It is midpoint of PB. You can find that PB, Q is a midpoint of PB. So we could have obtained its coordinate using the midpoint formula. Example number 9. Find the ratio in which y-axis divides the lines segment joining the points 5 comma minus 6 and minus 1 comma minus 4. Also find the point of intersection. Point of intersection. Now let we know that the point on y-axis can be given by as 0 comma y, because x coordinate will be 0 on the y-axis. So intersection point will be on y-axis because y-axis divides the given line segment. Now let if we assume that let the ratio be k is to 1, let the ratio k is to 1, then by the section formula the coordinates of the point which divides AB in the ratio k is to 1 are, coordinates क्या हो गए उसके, x y is equal to kx2 plus x1, that is minus k plus 5 upon k plus 1, ky2 plus y1, that is equal to minus 4k minus 6 upon k plus 1. The point lies on y-axis, and we know that on the y-axis the abscissa or x coordinate is 0. Abscissa or x coordinate is 0. Therefore, minus k plus 5 upon k plus 1 is equal to 0. Its x coordinate is 0. So here we put x comma y, then x is equal to 0. 0 is equal to minus k plus 5 upon k plus 1. Hence k is equal to 5. That is the ratio is 5 is to 1. Putting the value k is equal to 5, we get the point of intersection as 0 comma minus 13 upon 3. If you put k into in a y coordinate here will be y is equal to minus 4k minus 6 upon k plus 1. If you put value k, 5 is equal to k here, then you can find is equal to minus 13 upon 3. So the intersection point, that is equal to x comma y is equal to 0 comma minus 13, because here x coordinate is 0. So 0 comma y is equal to 0 comma minus 13 upon 3. Now example number 10. If the point A 6 comma 1, point B 8 comma 2, point C 9 comma 4 and D P comma 3 are the vertices of parallelogram taken in order, find the value of P. Now first for that just let's discuss parallelogram. What is a parallelogram? In a parallelogram, that we know that it is parallelogram A, B, C and D. So if we draw the diagonal of parallelogram, then we know that the diagonal of parallelogram divides are bisector of each other. AC and BD are bisector of each other, that AC divides AB in two equal parts, and also BD divides AC into equal parts, two equal parts. So we can say that the intersecting point of both the diagonal, it's a midpoint of both the diagonal. क्या होगा? जो AC और BD जो डायगनल है वो एक दूसरे को इंटरसेक्ट करते हैं, वो भी दोनों एक दूसरे के बाइसेक्टर है। तो बाइसेक्टर होने के हिसाब से तो P यहाँ पे जो पॉइंट मिलता है वो क्या होगा? दोनों का मिड पॉइंट होगा। दोनों का क्या होगा? मिड पॉइंट होगा। तो मिड पॉइंट के जो कोऑर्डिनेट्स है कि मिड पॉइंट P ऑफ AB, कोऑर्डिनेट्स ऑफ P ऑफ AC इज इक्वल टू क्या हो जाएगा? क्योंकि दोनों का एक ही मिड पॉइंट है। सो कोऑर्डिनेट्स ऑफ P of BD means here we just put the value and we can find the missing value. So let for that we know that the diagonals of a parallelogram bisect each other. Bisect each other means its midpoint is common. So the coordinate of the midpoint of AC is equal to coordinate of the midpoint of BD because its coordinate midpoint is same of AC diagonal and BD diagonal. So let midpoint of AC, that is x1 x3, x1 plus x3, x1 plus x3 divided by 2, y1 plus y2 divided by 2, y1 plus y3 divided by 2, and midpoint of BD x2 plus x4 divided by 2, y2 plus y4 divided by 2. So here we can find 15 divided by 2, 5 divided by 2 is equal to 8 plus p divided by 2 and comma 5 divided by 2. So we can compare the quantities of coordinates x with x and y with y. So here you can find 5 by 2 and 5 by 2 equal. So let me take 15 by 2 is equal to 8 plus p upon 2. Hence we can find p is equal to 7. Now you can solve such example from exercise number 7.2. Solve question number 1 and 2 as are given here are easy to find using this section formula.